We've been studying the differential amplifier, and so far I've been asking you to accept the special case where we can calculate gain. And that special case was that if R1 is equal to R2 and R3 is equal to R4, then the Vout is equal to minus R3 over R1, which represents the gain, multiplied by the difference of the two input voltages. I'm going to go ahead now and show you that that is correct and how that works. Here's an example of a differential amplifier with two input voltages, V1 and V2. Let's go ahead and figure out a formula for what Vout is. Recall the basic rules of op amps. In order to have a stable op amp circuit, the voltage on the positive terminal has to be the same voltage on the negative terminal. The op amp adjusts the output until both inputs are equal. The other thing to remember is that there is no current that flows into the inputs of an op amp because they are essentially open circuits. What that means in this circuit is at this point right here is a voltage divider created by V2 and the resistors R2 and R4. And I've written down the value of that voltage divider over here so that we can figure out what V plus is. Once you've found V plus, you've also found V minus. So we can write that up here. We can say that V minus is equal to V plus. And now that we know what the negative voltage is, we can figure out what the current through IR1 is. And I've got that here. IR1 is equal to V1 minus the positive voltage, because they're the same, divided by R1. Now here I've taken, there's V1 over R1, that term there, and then for the V positive term, I've replaced it with the value for V plus. Now the current that goes through R1 can't go into the input of the op amp, so it must continue on through R3 and then end up at the output of the op amp. This means that we can figure out what the voltage across R3 is by multiplying it by its current. And once we know the voltage across R3, we can ultimately determine what Vout is because we know what V minus is. If we take away the voltage that's across R3, we know what Vout is. And so I've taken our knowns and I've substituted in. This is what we said V minus is as a result of the voltage divider. And then this part here, that was just IR1. So this is IR1. And then we multiply it by R3. That is our equation for Vout. If I can reduce that down to V1, V2, and a couple of resistors, I'll be able to prove the formula for a differential amplifier. Now here's where things get a little mathy. And I don't expect you to reproduce this on command, but I expect you to remember that you've seen it and that the formula for a differential amplifier is justified. I want you to remember what the formula is at the end of the day. So let's take a look. So I take R3 and I multiply it by what's in these brackets, and then I expand that out into this point here and this point here. So this bit is this bit. And then I factor out the V2, so I take the V2 on these two terms and I bring it out in front here, and I group those terms into here. Then what I'm going to do is I'm going to replace R2 and R4 with R1 and R3, and this is for our special case. So here I've taken R2 and R4 and I've replaced it with R1 and R3. Then I'm going to put the V2 multiplier all over one term. So I cross multiply this and I put it over one term. I factor out R3 and R1. So I take R3 and R1 here and I factor out in front, and I'm left with R1 plus R3 over R1 plus R3, which cancels. So after all that work, I'm left with that Vout is equal to R3 over R1 times V2 minus V1. So R3 over R1 is the gain of the differential amplifier, and V2 minus V1 is the difference between the input voltages.